Let us study Archimedes Principle. I hope you might have studied Archimedes Principle at a basic level in your early classes. Now we are going to define it first and then we'll study about some detailed applications of Archimedes Principle. And this principle states that a body, whether partially or completely submerged in a fluid, is buoyed upward by a force due to fluid pressure that is equal to the weight of displaced liquid. This is the Archimedes principle. This is the statement which you can always keep in mind. And a body which is buoyed upward by a force which is due to the fluid pressure that we can calculate also. Say, for an example, we are given with a container in which liquid is filled up to a given height, and inside it, say, we submerged a cylindrical body which is of height h and its base area is s. It is submerged in such a way that its top level is at a depth L below the free surface of liquid. In this situation, we can simply state due to the fluid pressure on the top face of the cylinder, top circular face, a force F1 will act in downward direction. At the bottom face, a fluid pressure will exert a force F2 in upward direction. And on the lateral surface, as we already discussed, the force due to fluid pressure is normal to the surface. All these forces will be acting in horizontally inward direction. So all these will get cancelled out. So here we can simply state that buoyant force on object is, here this buoyant force which we can write as Fb, this must be F2 minus F1. As we know, net upward force will be F2 minus F1. And in this situation, F1, F2 can be easily obtained like the location where F1 is applied. If we consider point X, then pressure at point X due to fluid weight can be simply written as L rho G. Or net pressure can be taken as P atmospheric plus L rho G. And if there is a point Y which is just below the bottom face of the cylindrical object, Py can be written as P atmospheric plus the total depth of the point Y below the free surface of liquid is L plus H. So it will be P atmospheric plus L plus H rho G. Now in this situation, if we wish to calculate the value of F1, which is the force acting on the object due to fluid pressure, will be Px multiplied by the area S. So it can be written as P atmospheric plus L rho G multiplied by S. Similarly, F2, which is acting in upward direction, will be Py into S, which can be written as P atmospheric plus L plus H rho G multiplied by S. And if we find out the buoyant force on the object, this Fb, we can see, if you subtract F2 minus F1, if you calculate, this will give you Hs rho G. And here Hs will be the total volume of the object, which can be written as V rho G. And rho, we have taken here the density of liquid. So the product of volume of object and the density of liquid gives us the mass of liquid which is displaced by the volume of this body. So this V rho G can be written as weight of liquid displaced by the object. So this is what we have written earlier in Archimedes Principle, that the total upward force or the buoyant force acting on object is given as weight of liquid displaced by the object, or it can be written as V rho G, where V is the volume of liquid displaced, rho is the density of liquid, and G is the gravity. So this is the way how we calculate the buoyant force acting on any object which is submerged. If the object is partially submerged in the liquid, then in this expression V would be the submerged volume of the liquid, because the liquid is displaced only by the submerged part of the body. Let's have more applications on Archimedes Principle. In continuation, let's discuss law of flotation. Say if we consider a body which is floating in a liquid, so this is a body which is floating in a liquid, then we can simply state, when a body is floating, it will be partially submerged in the liquid, and say if V is the volume of body which is submerged in the liquid, so we can simply state the buoyant force acting on the body can be written as FB is equals to V rho G, and its weight will act in downward direction mg. If we draw the free body diagram, we can simply state, for equilibrium of floating object, we can directly write in this situation V rho G must be equal to mg, or we can simply state the net buoyant force acting on body has to balance the total weight of the object. And you can see here also in buoyant force we are using the expression V rho G, where V is the volume of liquid displaced. In this situation, it is the volume of the object which is submerged in floating situation. This is the way how law of flotation is defined.